Hi, thanks for having me. So on the program, you have a title that says Corruption Evidence from Administrative Data. So when I sent the proposal, I had in mind a paper about public procurement, which is also based on administrative data. But this morning, Igor convinced me, no, you have this other paper I thought you were submitting. And that paper is on license plates, and it's much more interesting for the audience. So I complied, and I changed my topic completely, and I will talk about the license plates. So this is joint work. The list of authors is eternally growing, because it's a whole series of papers eventually. But what I will try to do is try to walk you through the basic ideas here. So what we talk about is this. This is a picture of a Russian car, and I'm sure every one of you that has been in Russia has been observing this. In Russia, there is a strange correlation between expensive cars and special plates. And why is it interesting? It doesn't seem to be very interesting, because it is the case in any country. In many countries, you see expensive cars driving around with expensive plates. And it is linked to vanity. People want to show that they're special, and they buy the plate. Why is this interesting? It is interesting because in Russia, in the period we are studying before 2013, it's illegal. So there should be no correlation. You cannot buy the plate. The plate is officially, at least, allocated completely randomly. So there should be no correlation whatsoever between how expensive the car is and how expensive the plate is. But there is a correlation. So the whole idea of the paper is, we got to think about the paper by walking around in Moscow and seeing these kind of cars all the time and thinking, oh, this is normal, until someone pointed out, well, it's not that normal because it's actually illegal. The pattern shouldn't be there. That made us think, maybe we can use this to measure corruption. And that's the simple idea of the paper. We're going to try to use the correlation between how expensive the car and how expensive the plate is to measure correlation. So what do we have? We have license plate data from 1994 till 2006. We are broadening the data set as we speak, but the data set is very extensive. It's a real administrative data set, so it means you have the chassis number, the license plate number, you know where the license plate has been allocated, you know where the people live, you know whether they get any penalties for driving too fast, you know whether they lose the driving license, you know all that kind of things. So are we going to use that information to try to back out an interesting effect? Okay, so what I will present first is a kind of Mickey Mouse model. And the only purpose of showing that Mickey Mouse model is showing, with some very simple assumptions, you can actually get a measure of corruption by looking very simply at the difference between how likely it is that you have a special plate and how likely it is that you have a special plate in reality if you have an expensive car. So the normal likelihood to have a special plate is more or less, or any plate, is more or less 3-point-something%. That's the random probability of having a certain plate. But then you see that with expensive cars, the expensive plates are sometimes as likely as 20% instead of 3%. And what the model is going to deliver is to say this difference between the actual likelihood to have a special plate and the theoretical likelihood is a measure of corruption. That's the only purpose of the model. It's a Mickey Mouse model. So what is it going to rely on? It's going to say, look, agents care about, and later on I will say, this is probably wrong, because other things are going on, and there's more interesting stuff, and so it's work in progress. But so we're going to assume for now that people care about vanity consumption. You want to look special, you want special plates. What matters in that case is that if people see you drive around with a special plate, people actually believe you bought it. Because if you drive with the plate 00AAA or something, and people think, yeah, but you just got it by luck, it is not going to buy you any vanity. People have to perceive the corruption. People have to think you actually bought it. That makes it valuable for the vanity in this context. So that's the problem. You could get it by luck, and this blurs the signal. You want to signal, I'm special, and the signal is blurred by the fact that you could get it just completely randomly. That's the thing. So basically, the model is going to solve this by saying, look, if the luxury of the car is complemented by a signal, the signal is getting reinforced. And that's what it is. So, okay, let's go to the model in a very short, like 2 slides, maybe 3 slides. We're going to assume some share of the population could be corrupt. They're not necessarily choosing to be corrupt, but they could be corrupt. They're willing to be corrupt. And there's another share of the population, 1 minus C, and they will never be corrupt, even if they could or they would. So there's a number of corrupt agents, C, but that doesn't mean they actually are executing the corruption. They would be willing to do if they have a chance. And we're going to use utility function, which is also very simple. People are going to derive utility from 2 things. They have a certain budget, they will have resources, that's a budget they have. From income, and we assume anything else away, they just, income comes, bah, they get an income, and they spend it on vanity plates and luxury cars. Yes?
A little bit missed. So, what is the final goal? You want to construct index across region, use this data?
What, okay, the goal...
Where are we going?
We're going to evidence-based measure of corruption. Because the problem is, most measures of corruption are based either on perceptions, you ask people, and that can be very wrong, or they are based on actual scandals, but then it's intertwined with media freedom, because in the most corrupt countries there's no scandals revealed, or it's based on expert assessments by some agents. And all these things, is a huge literature explaining all the problems that exist with these measures. And what we are on a research agenda trying to look at measures of corruption simply based on actually evidence, real evidence from administrative data. And we are working on 2 data sets at the moment, actually 3, but 2 are far advanced: public procurement, governments buying stuff from private markets and corruption in that market, and license plates. But the idea is an evidence-based measure of corruption. Okay. Thanks for the question. That needs to be clear to get people with me. So, and how is the timing of this simple game? Agents will receive a plate randomly. And so imagine all of us want a vanity plate. And imagine you are the corrupt guys and you're the non-corrupt guys. So what will happen first? First, each of you will get a license plate. You buy a car, you get a plate. And then the people that are corrupt, that was you. You're the corrupt guys, right? Or you're the non-corrupt guys. You're the corrupt, whatever. You're the corrupt guys. Then, if you did not get a special plate, you could decide to buy a special plate. You cannot, because you're not willing to be corrupt. That's the timing of the game. Huh? So you could try to swap your plate for another plate. So what will it mean? If you are corrupt agents, for the people on the right side of the room, your right side of the room, you could either do alpha or beta. And alpha is going to be your payoff if you buy the plate. So how does that look? What does it mean? So pi is the probability that people actually believe you bought it. So that will mean that if you have pi here, the value of vanity is 1. And with 1 minus pi, the value of vanity is 0. So you have 2 possibilities. People believe you actually bought the special plate, and then you get a vanity value. Or people do not believe you bought the special plate, and then you get no vanity value. But if you don't buy the plate, so remember, we have allocated the plate already, and then you can decide. So the point is, if you do not buy it, you will have this thing, 0 vanity. Huh? So what is the rest of the things here? You have a budget. The budget is R, the resources. And so what people do is they buy a plate that gives you a value 1, normalized value 1, and you can buy a number of cars with your budget. And actually, we see in the data set, some people have up to 10 cars. It's really crazy. So it's not the case that people buy 1 expensive car. They buy many expensive cars in some cases. And so what you will be able to do, if you wait a second. If you buy this vanity plate, it will cost you the price of a bribe. So this is the size of the bribe for buying the plate. So that means you have your budget minus the bribe divided by the price of a luxury car. So basically this thing says you how many luxury cars you can buy after having bought a special plate. Right? And so what is this? This is the utility of having a vanity plate and a number of luxury cars if people believe it's a vanity plate, plus the same thing if people do not believe it's a vanity plate. This is the value of being corrupt, and this is the value of being non-corrupt, of a corrupt agent. So the corrupt agents have to decide, will I do alpha or will I instead do beta, right? So this is it. Now, the important thing, how do you define pi? Well, pi is going to be very simple. It's really a workaround to be very simple. Pi is going to be defined as the probability, the simple probability of special plates with a certain type of car relative to the real random probability. So this, let's define a phi, and phi is defined for every level of luxury, and phi is the share of vanity plates for a given luxury level. So for example, for Bentleys, we find 20% or something. 20% of the plates are special, but it should be only 3%. So the phi for the luxury level Bentley would be 20%. And P is going to be the actual expected share, 3 point something percent. So this pi, the pi that people think it is really bought by bribing as opposed to by luck, is going to be the relative difference between the 20% with Bentleys minus the 3% that should be random divided by the 20. So it's the relative difference between the random probability and the observed probability. That's going to be my simple workaround for this, this likelihood that people perceive it as a vanity. And then what you're going to do is something very simple. You're going to say, okay, let's find the equilibrium very simply. Let's find this number of resources where corrupt agents are indifferent between actually buying the plate or not buying the plate. Because if you have a too cheap car, it doesn't pay buying the plate because people will not believe you bought it. So the thing is, there is an equilibrium given you resources. There's an equilibrium luxury level where you will buy or not buy the plate. Because if your car is too cheap, you're not going to buy it because people don't believe it anyhow you bought it. So, and that gives you the correlation in an equilibrium for corrupt agents between expensive cars and expensive plates. And so that's how it looks. So you have this equilibrium. So let's watch here what happens, right? So you have this equilibrium, this is an equilibrium resource level R, and that means there are two luxury levels crossing this line. And so what it basically means is if your luxury level is above H, every corrupt agent will actually be corrupt. If your luxury level is below lux L, every corrupt agent will decide to be not corrupt. And between the two, there's some kind of unclarity. But we don't need to work it out. The only thing we need for our purposes is from a certain luxury level, in this case lux H, all corrupt agents will decide to be corrupt. So if the car is expensive enough, all corrupt agents will buy a plate. And this gives us the following thing then. This gives us this. So this will mean that we can relate this phi and the actual probability, the random probability 3%, and you get a measure of corrupt agents. So in a sense, basically, what we're saying is you're getting a direct measure of corruption by relating the luxury level and the actual probability. So the percentage in luxury cars and the actual probability if the luxury is high enough. So for expensive cars, this gives you a very simple formulation that the level of corruption is a linear function of this thing. So, and that's what you're going to use. Okay. So, how do we... Now, this is all very nice in theory, but we are reading an empirical paper. So the question is, how do you define vanity? How do you define luxury? There's many ways you could do it, many ways. And we're still fighting with that. But so we actually have now 3 ways that are just next to each other. One is the luxury car list of the Russian government. There is a list called a luxury car list, and they have higher taxes. So basically, of all the cars, we have all the brands and the types and the year. So we know all the details of the car. And we call that luxury if it's on this list. Another thing is you have the European car segment. So you have European car segments, and one is luxury cars, another one is sports cars, and we take these special cars in the European definition and call that also luxury. And also then you have car brands, right? A Volvo or a Volkswagen could be anything, but a Maserati, a Bentley, or a Ferrari can only be luxury. So really special brands will be by definition luxury cars. So these are the three ways we kind of try to back out luxury. Okay. How do you define vanity? That's more difficult even. So vanity could be letter vanity or number vanity. Because how does a Russian car license plate look like? It looks like a letter, 3 numbers, 2 letters, and then a region. So the first thing we did is look at the numbers, and you could, for example, imagine 001 is special, 000 is special, 777 is special, 999 is special, and so on. The same for letters. What is clearly special is 3 the same letters. But here we are still very far from finished, because apparently in every region in Russia, certain letter combinations have special meanings. And actually what we're in the process of doing now, but it's unfinished, is going to all these regions, talking to people and ask, what is the special combination in your region? And then actually code this. But what we did up till now is just look, within expensive cars, what number and letter combinations are much more prevalent. So we basically look at the data to define the thing. This is what we come up with until now. For the letters, it seems really reasonable, right? All the things with 2 zeros in the beginning, everything, all the round numbers, 100, 400, 300, 800, and all the triples, 777, 888, and also the symmetric ones, 707, 505. So there seems to be some beauty involved here in the numbers. So that makes a lot of sense. If you talk to people, they think it's okay. The letter vanity is much more tricky, actually. Some people say, what does this mean? What does this mean? And some things are really clear for people. Other things are not clear at all, in fact. So what we find, this is just given by the data, is that all the triples are there. So that's nice. So you have AAA, you have MMM, all the triples are there. But this is also clear, it has a meaning. But a few other ones are pretty unclear. It seems to be if you have two the same letters, it's much more likely to show up 2 E's and all. But some of the things we don't quite understand. So we have more work to look into this. But what we will use in the results is mostly the triple. Because that we are sure this is something special to people. Okay. So just to show you the luxury thing with the brands. So you have Ferrari, Bentley, Maserati, Lamborghini, Hummers, Rolls-Royces. These guys do not have non-luxury cars. They are luxury brands. And so the expected probability is 3-point-something percent, 4%, depending on how you define it. And these guys are way above it. So clearly, they're buying plates, although they can't buy plates. Really. You see? That's kind of nice. This is the European car segment. And again, so this, look at these classes, E, J, S, that means executive cars, luxury cars, SUVs, and sports cars. So F is the luxury car. Huh? That's what we're looking at. And the lines, the lines are the theoretical probability and the probability in our data set for all the cars. These are these 2 lines, and these are very close to each other. Something below 4%, 3-point-something. And this is the real probability. So a lot higher, a lot higher. So again, whether you take this definition, the brands, or the European thing, it doesn't seem to matter much. Wait, I'm jumping. So what do we have here? We have our definitions from vanity. I would say look at the number vanity and look at the letter vanity. The letter vanity 3, let's focus on this, is the triples. And then you see here what is the expected mean and what is the actual mean. And then the differences. Okay. then look at, this is for the whole population. Huh? There's nothing much there. There's some differences, but very small. But then look at, so that this means the vanity thing by itself doesn't seem to work. If you don't correlate with luxury cars, there's no pattern, no clear pattern. But now if you say, okay, let's make this conditional for luxury cars. So we do the same thing as before, the previous table, but now we only do it for luxury cars. Look at the expected mean, theoretically, and the real mean. 3%, 8%, 3%, 6%, 3%, 5%. So huge differences. So there's something very strange going on. And then, I mean, these are different variations of the same thing. And you see the same thing popping up. So you have the luxury 6, you have the luxury 1, same pattern, basically. So it's robust. Which brings us to our first set of regressions. What you could do is you could regress this measure of vanity we have on the luxury. And so the letter vanity, the number vanity, how special the number is, should not be related to luxury if the plates are allocated randomly. So if we have any correlation, it is very strange. And you see, look at, these are the t-statistics. Of course, it's a lot of data, but you get very, very strong correlation that are extremely far away from zero between the vanity and the luxury. So very clearly, more expensive cars are more luxurious, more vanity numbers, like this. Especially for luxury 6, it's really a really big effect. So that's interesting. Okay. Now we're coming to the initial question, why do we care? We just now show a pattern, how can we use this? Well, the first way we are using this is, okay, we could, for example, look at government officials. So the interesting thing is, local city administrations, the judiciary, the federal drug control, the federal immigration offices, the GIBDD, which is the traffic police, higher authorities like parliament and so on, the MIA, internal affairs, the state security, this is basically FSB, and the Supreme Courts, they have special letter combinations. So we know from the plates who these people are. And you can see, so for people working in these offices, whether they are different, whether they differ in any way from the random pattern. And it seems that the real interesting thing is people working for state security, they have really a very strong coefficient. So they're much more likely to have special plates. But okay, that's not all too surprising. So more interesting is, and now we're really getting at your question, we also know where these people are born. So we get a measure of corruption by looking at the correlation. I showed you the regressions, I showed you the correlations. What we can do now is we can do this regression, but split people by region of birth inside Russia. And especially for this, to do this thing, we look only at people living in Moscow. So you have people living in Moscow, but coming from all Russian regions. And you do regression by region of birth, and you get different betas, different correlations. And this correlation is, if our model is more or less correct, a direct measure of the corruption level. Because the P's are the same for everybody. The only thing that difference is the C, right, in our model. So now we have a regression by region of birth, and we interpret this correlation as a measure, a linear function, the C is a linear function of this correlation. And the P's are the same, so it should be a direct measure. So, and this is what you get. You get a map of Russia with measures of regional corruption. And it's not based on some surveys, it's based on actual behavior, which is kind of nice. And the underlying reasoning is people take their social norms from the region of birth to where they live. What we do here, forget about all this table, the only thing you should look at is this here. We basically have our vanity. So we have letter vanity, have the combination, and we look how much is correlated with measures of bribery. And the last one is acceptability of bribery. So it's an all-Russian survey that asks over time how acceptable you think is bribery. And so the correlation with our thing is 68%. So it seems to be that we have found an evidence-based measure of how corrupt people behave, and that it correlates very well with the best measure we have of corruption of individual people in these regions. You could also look at the time trends, and you see that it is actually going up over time. So people in Russia, over this period of time, are getting more corrupt. The coefficient is going up. So corruption seems to be an increasing problem in Russia. You also could look at it by year of birth. And if you look at the year of birth, you see that there seem to be, this is very weak and we have to work further. Some of the samples are really small, but not so small. We have been looking into that. And you see that it is going up in the run up to the transition, and it's going up in difficult periods. So if people are born close to or just after very bad periods in Russian history, those people tend to show up as to be more corrupt in our data set. Of course, you have huge problems of selection, not everybody survives and all that, but there seems to be an interesting correlation we didn't expect, the year of birth and the calamities in that year, and how corrupt you are later on. So there seems to be an interesting agenda there later. What we do have is multiple channels. So one of the things, and now I'm going to say maybe we should go further. Maybe people do not only buy plates for corruption, thank you. Maybe they also buy something else. Maybe if you drive around with a special plate, the police won't stop you. Maybe if they stop you, you're less likely to get a fine. Or maybe you're not less likely to get a fine because you're more likely to pay the police officer too. Who knows? So maybe if you get a fine or you get an accident, you're less likely to lose your license plate. If this is true, you should also be more likely to get an accident, comparing with the same luxury cars. And all these patterns we do find. So now we're working further, we see, take a luxury level, take Maseratis or take an expensive car type, and compare the guys with special plates to the non-special plates. The special plates are less likely to have a fine. They're more likely to have an accident. They're less likely to lose the driver license. So it seems to be that it's not only corruption, you're also buying something here. You're buying some kind of, so you, by signaling your connection, you buy some protection. And we are far away from actually solving this, but this is the way we'll go further. And this is just showing this thing. So this for the likelihood of fines, and this is for, I have to jump this because I have no time, this is for losing the license, and you see that if they lose the license, they lose it for shorter periods. So less likely to lose it if they lose it shorter periods. So what are the challenges, basically? Let's jump the challenges. Let's go to future research. So basically, we think we can look into historical roots of corruption, to some extent, based on this evidence-based thing. But that's going to be tricky because many things are far ago. Much more interesting, we can look at local government corruption. So what I showed you is a map by region of birth. But you can also do it. We know who is working for the local city administrations. So we can do it by city. We know where people live, and we know whether they work for a city. If they live in a city and they work for a city, they're likely to work for that city. I mean, we know how many of people have bought a plate. So if you are in a city administration and you are willing to be corrupt on the buying side, you're probably also going to be corrupt on the other side as a government official. So you could turn this in an index of corruption at the city level. Thank you. And this is the next thing we will try to do, and then try to link this to performance of these cities in terms of SMEs, economic growth, innovation. If they're more corrupt, it should be less good. We could look at police department corruption, because in the model, I have assumed it doesn't matter where you ask the plate. But actually, if you look at the data, you see that some police, we also know the police department where you ask the plate. And the special plates are concentrated in some police stations. They are not all equally corrupt. I'm not sure we want to do this because it could get us in trouble, I suppose. So I think this is going to stay a nice idea which we will never actually do just to be able to still travel to Russia. And the last thing is we look at traffic accidents. So the last thing we will do is, okay, I forgot about this, I have no time. Okay. So skip this thing. But what we will do this, we are looking at it right now. We look at traffic accidents by city. And so maybe there's a welfare cost. Maybe this kind of be, if you can buy your way out of the police, you could actually get the welfare cost and more accidents. Okay, I have to, it's still time for questions? Question time, sorry, yes. I'm sorry for talking too much, it's always the same thing with me.
Thank you. Did you take into account the price of the plate itself? I mean, if it would be too low, let's say, more people will be willing to buy it, or vice versa. Well, I don't think that the expensive plate would stop one, but if the price would be decreasing, for example, or what would happen if it would be legalized?
Yes. First of all, in the period we have it, it's not legal, but there are data sets on the prices. The prices, we are downloading these prices now, and we see the prices run from 5,000 euro to 120,000 euros. So it's not like a few euros. It's amazing. So in rubles, it's a lot more, but if you translate it to euros, it's a sizable amount. It's scary, actually, you think. So in the model where we say the budget minus the price of the plate divided by the luxury, it's a sensible model because the plates are actually sometimes more expensive than the car, or equally expensive, which is interesting. So how did Russia solve it? So you could ask yourself, why do they have this? Why don't the governments exploit this? Well, what they did is they made a law in 2013 where you cannot still buy plates, but what you can do is you can sell the car with the plate and buy it back without the plate. So you get online exchanges where you see both prices and you have an inferred price of the plate. And we're downloading this too, and we have now 30,000 of these, and you see the values are really high. So now we have actually markets of these plates, and you see the prices are very considerable. Thank you for the question.
Comparing two numbers, demographic slide and your data set, I wonder if the people on the right side who are born in 80s or 90s even were allowed to have a license in 26,
yes.
I think?
Yes. Yeah.
Thank you.
You're referring to... wait. You're referring to this? Let's go. To this one, right? Yeah. You told, so remember, we go till 2006. Huh? So 1980, 2006, that's 26. So you can drive from your 18, but you're right, of course, the sample will diminish and diminish. So at the very end, it's like 86, and we have till 2006. So these people, at the very last 2 years, are 18 to 20. But of course, you're right, there will be some selection there, right? So only rich kids would buy a car if they're 18 to 20, or rich parents. So there's going to be some selection there, and that's going to be problematic, definitely. So we have to take that somehow into account in the further studies. Yeah. But it's not that there's nobody. There are people there, and that's why we also stop the line here. It doesn't make any sense to continue the line because then you have no observations, or if you have observations, there are going to be mistakes. Yeah. Any more questions? If I'm allowed? I'm not allowed. Okay, I'm not allowed. No more questions. In the coffee break, maybe. Okay, thank you so much.